Hey friends, so here's what we are going to do today. I hope you had a great and restful weekend, and I want you to make sure that you're ready to roll today. All right, so let me show you something for your Canvas. If you have assignments that I have emailed and said, hey, you need to do XYZ, here's how you find that. So this blue tab, or the one that says this week's assignments, that is on just the weekly assignments for this week that has changed over as of Monday morning. But if you need to see last week's assignments, here's where you click the green button, or the previous week's assignments. And I want you to see that it says August 17th through the 21st, scale copies assignment. And these are things that you've got in previous weeks. And then as we end this week, I'll add in another one and another and another. So you guys, everything is graded. So make sure that you get it done. You'll see in PowerSchool, as I grade things, it shows up in PowerSchool. So you can check PowerSchool to see if you have anything missing as well. And I really like to do this because I don't give y'all a lot of work, but I expect you to do the 2 or 3 questions I give you each day. So you guys can do this, get it done, you'll be good to go. Okay. Here we go. Today is Monday, August 24th, and today we're going to talk about scale drawings. Make sure that you have a notebook and some paper out, and we will get started. So our goal today is to be able to explain what a scale drawing is and explain what its scale means, and use a scale drawing and its scale to find an actual distance. So let's talk about scale drawings. We've talked in the past week about scale copies. A scale drawing is very, very similar, if not exactly the same. We're just talking about a drawing of something real versus a drawing of a shape or a letter, okay? So here are some examples of scale drawings and not scale drawings. This first image is a scale drawing of a school bus because it looks very similar to what a school bus is actually shaped like, from the back end at least. This picture is more of a cartoon image, so it's not a scale drawing. This is a scale drawing of a quarter. Obviously, this looks like a quarter. It's just not exactly the same size. And this drawing is of a quarter, but it's a cartoon again. This is a scale drawing of a city map, and you see how the roads are curved and that kind of thing. This one is a subway system, and it's not perfectly drawn to scale because subways weave in and out of different places, okay? So we're going to talk about a basketball court first, but on your Canvas assignment, there's another video, and this just talks about you being diligent and having discipline. And it's talking about a sport, but this relates to anything. This can relate to dance. It can relate to school. It can relate to just anything that you love, that you really want to do well and you're a team player at. For you to do well at it, you have to do the same thing when nobody's looking, okay? So make sure you pay attention to that, and just have some Monday motivation, okay? So let's do this. That's not going to work. All right. I think I want to do that. I'm trying to make sure that you guys can see my video. Okay. All right. I think that you can see it. I hope that you can see it. All right. So let's get started. So here we have a scale drawing of a basketball court, and it's very well to scale because basketball courts have to be very uniform. And what has happened is you have different lengths that have already been measured for you on this scale drawing. And then you have this thing called a scale. So let's look at it. It says length A is the length of the court. That's 14 centimeters on the scale drawing. The width of the court, 7.5 centimeters. Hoop to hoop, C, is 12.4 centimeters. And 3-point line to the sideline is 0.5. And it tells us that the scale is 1 centimeter to 2 meters. And then we have this table, and we're going to find the actual court lengths for each of these things. So first thing we need to do is we need to write our scale down in relation to what we have. So we have two different measurements here. We have centimeters and we have meters. Centimeters is going to be our scale drawing. So I'm going to write 1 centimeter and I'm going to put our actual distance 2 meters. And what we're going to do is we're going to find the scale factor, just like we have been doing, from centimeters to meters. 1 times what number gives me 2? 1 times 2. So I know that we're multiplying by 2. Excuse me. So I'm multiplying by 2. If I have a scale copy or scale drawing, I know that I'm going to multiply every number by 2. So 14 times 2 is going to be 28 meters. 7.5 or 7.5 times 2 is going to give me 5 times 2 is 10, 7 times 2 is 14, plus 1 is 15, and I got to add that decimal in, meters, excuse me. 12.4 times 2 is going to be 8, 4, and 2, and I add 1 decimal place, 24.8 meters. And 0.5 times 2 is going to give me 10, but I have to add a decimal, so 1 meter. All right, so you see how using that scale factor, we can go from the scale to all the actual distances in our basketball court, okay? So one that's a little bit different. If the scale is 1 inch equals 3 feet, how tall is the actual tree? And this is our model tree. So let's see. I'm going to set it up exactly like I did for scale copies, but instead of using our O and our C, we're going to use our units of measurement. So I'm going to put inches here, and I'm going to put feet here. Let's take our numbers from the scale, our values. So I have 1 inch and I have 3 feet. And then this says 15 inches. Am I going to put that 15 in inches or feet? I'm going to put it under the inches. And I want to know how tall the actual tree is in feet, so I'm going to put a question mark here. You can put the variable there, whatever works. The next thing I'm going to do is find the scale factor. So 1 times what number gives us 3? Any number times itself is that number. So, any number times 1 is that number, excuse me. So 1 times 3 is 3. We know that the scale factor here has to be the same because this is a scale drawing or a scale copy. So 15 times 3 then gives us 45. But something important to always remember when we're talking about scale drawings, you always have to write your units of measurement, okay? Because this could have been 45 inches, 45 people, 45 something. You need to tell me what that is, 45 feet for the actual tree. Okay, so this right here is exactly the same thing we've been doing for scale copies, but now we're talking about scale drawings. All right, so we have this question. While on a camping trip, James made a sketch of a sequoia tree, and a sequoia tree is just a really, really big tree, and a lot of them are really, really old. So what is the actual width of the tree in feet? Okay, so let's write down what we see here, what we need to find. James made a sketch of a sequoia tree. Okay, great. But we have this scale here, and we have the dimensions, and we want to know the actual width of the tree in feet. Okay, cool. Well, which value does width show? Width, remember, is how wide something is, and I want to know how wide that tree is, so I'm going to measure this 0.4 centimeters, okay? So I'm going to compare centimeters to feet, so I'm going to write centimeters and feet, and I know that 1 centimeter is equal to 100 feet, okay? And then I'm talking about width of the tree, so I've got 0.4 centimeters, and I don't know how many feet. First thing to do, find our scale factor. 1 times what number gives us 100? 1 times 100. And I have 0.4 times 100. Okay, so I'm going to multiply 100 times 0.4. 0 times 4 is 0. 0 times 4 is 0. 1 times 4 is 4. And I move 1 decimal place, and I get 40 feet for the width of my tree. Let me show you one more way to do 0.4 times 100, especially when we're doing percents. So 0.4 times 100, there are 2 zeros here. So that's 2 multiples of 10. If I take 0.4 and I take that decimal and I move it 2 times from in front of the 4 to now behind a 0, there's my 40 feet, okay? We'll talk about that more when we get to percents, but I want to make sure I show you. All right. Now we have a word problem, which we love, but we're going to break it apart. You need to get a highlighter or a pencil and make sure you can underline or highlight things. And let's read this. And we're going to stop after each sentence and highlight the important things. So, a scale drawing of a school bus has a scale of 1/2 inch to 5 feet. Okay, let's stop. A scale of 1/2 inch to 5 feet. That's important. It's got some numbers in it and it tells us the scale. If the length of the school bus is 4.5 inches on the scale drawing, what is the actual length of the bus? Okay, let's highlight what we need to know or what is important. If the length of the school bus, so length of the bus is 4.5 inches on the scale drawing, what is the actual length of the bus? That's what we want to know, so I'm going to circle it. Okay, so we don't have a drawing here, but we don't need a drawing because we have this scale. We are comparing inches to feet. So I'm going to put IN for inches and FT for feet. And I'm going to write my values down. I've got 1/2 inches and 5 feet. And I'm going to check that off to know that I wrote it down. And then it says the length of the bus is 4.5 inches on the scale drawing. So 4.5 inches goes here. What is the actual length? Well, I don't know, so I'm going to put the variable there, okay? So first thing again, find your scale factor. 1/2 times something gives me 5. Well, now I'm going to divide because I need to do the inverse operation. Well, now I'm dividing by a fraction. Well, didn't we learn last year how to divide by fractions? Okay, when we divide by fractions, we need to keep the first one, change the second one, and flip. So that's KCF, but that's called inverse operations, okay? So I'm going to do the opposite of dividing by 1/2. I'm going to multiply by 1/2. So I have 5, and I'm going to make it a fraction. Instead of dividing, I'm going to multiply, and I'm going to flip this 2 because I'm going to do the inverse, okay? Now I multiply my fraction straight across numerator and denominator. 5 times 2 is 10, and I get 10 over 1. So my scale factor is 10. So that means my scale factor here is 10. I think that it's going to be easiest for me to change this fraction to a decimal. I know that 4 1/2 is the same as 4.5. So now I'm going to multiply 4.5 times 10. I know that 5 times 0 is 0, 4 times 0 is 0. Because this is in the tens place, I don't have any ones. So I have 5 times 1 is 5, 4 times 1 is 4, and I have 1 decimal. So I'm going to move my decimal. Oh, excuse me, I need to add. I apologize. So now I need to move my decimal 1 time. So my answer is 45 feet. All right? Okay. And remember, you can always go back and rewatch this as you need to. All right, let's do our last one. Get your highlighter out and let's highlight the important things as we read. A scale drawing of a lake has a scale of 1 centimeter to 80 meters. Okay, we have a scale of 1 centimeter to 80 meters. If the actual width of the lake is 1,000 meters, what is the width of the lake on the scale drawing? So it tells us the actual width is 1,000 meters. And we want to know the width on the scale drawing. All right. And then it says explain or show your reasoning. Us solving the problem out and showing our work is us explaining it, okay? So let's write down, what are we comparing here? Centimeters and meters. I have the value of 1 centimeter to 80 meters. And then it says the actual width is 1,000 meters. So that 1,000 goes under the meters column. And then I want to know the width in the drawing. Okay, first thing again is, you got it, find your scale factor. And I know that 1 times any number is that number. So that's why I know every time that's 80. So now I know that something times 80 is equal to 1,000. So I don't know off the top of my head what this answer is, but I'm going to use the inverse operation and do 1,000 divided by 80. All right, I don't know that off the top of my head, and I could simplify that, but I would keep going. So what I need to do is I need to divide with long division. 80, does it go into 10? Or does it go into 1? No, put a placeholder 0. Does it go into 10? No, put a placeholder. Does it go into 100? Yes, it goes into 108 one time. 1 times 80 is 80. So I'm going to subtract that from 100 to see what's left. I got 20. Now I'm going to pull down this 0 and see how much 80 goes into 200. Well, I don't know that off the top of my head, but I do know that 8 times 2 is 16, and that's a little bit less than 20. So if I added that 0 and said 80 times 2, that would give me 160. So I think it's 2, and I got 160. If I subtract, my remainder is 40. Well, I need to have a decimal number, I guess, because I keep having a remainder here. So there's nothing after this 0. So it's understood that there's a decimal there, and then as many zeros as can be. So I'm going to put a decimal here, and then I'm going to pull down this 0, 80 into 400. So I know that 8 times 5 is 40. So I'm thinking that 80 times 5 is going to be 400 because I have that extra 0. That would be 40 and then another 0. And I'm right. 80 times 5 is 400. And now I don't have a remainder. So 12.5 centimeters would be the width of the lake on the scale drawing. And notice every time I find my answer, I circle it or put a box around it so that it's very obvious what my answer is, okay? Let me show you what you're gonna do for homework, and then you may go work. So you guys are going to do 3 questions very similar to what we've done in our practice today. You are going to find how tall this actual seahorse is, and this is probably like a plastic replica or something. Obviously seahorses are pretty small. But do not forget to show your work, and do not forget to write your units of measurements and circle your answer. For the last 2, you're going to read through, highlight the important things, and put your work and your units of measurement and circle your answer for these, and then you should be good to go. Make sure that you have your work done for last week. If I sent you an email, please make sure you go back and check your email and look at it and see what you need to do, okay? Hope you have a great day.